Hey everyone, Mr. Voigtkin here. This is lesson 1.10, 1.10, patterns in algebra, and you'll find this lesson on pages 35 through 38. So before we start looking at and reviewing what you learned last year in algebra, we need to learn and refresh ourselves with some of the vocabulary. So the first thing you need to understand is, what is a term? Well, a term is a number. You know what a number is. So examples would be like 6 or -4 or 18, or a variable, which later we'll learn a little bit more depth about this, but it is just a letter or a symbol such as X, Y, or Z. And the main thing you need to realize that it is going to be separated by a positive plus or a negative minus. Okay? So now let's take a look at this first example. We have 6 plus. So there's that plus. So how many terms do we have? We've got 1 that's on the left, and we have 1 that's on the right. So we have 2 terms, and this happens to be called a binomial. Now the next one that you see, how many plus or minus signs do we have? We have 1, 2. So that is going to be separating 1, 2, 3 terms. So an expression like this that has 3 terms is going to be a trinomial. Again, we have another trinomial down below. I can see that right away because there's 2 plus and minus signs, and that's separating 1, 2, and 3 terms. So what if we have only 1 term? Can we have that? Well, yes, we can. So something like 6x. So in this case, we only have 1 term, and that would be called a monomial. So there is only 1 term. Okay, now I've been using this word term a lot, and let's look down below. I've got a whole bunch of terms sort of spread out here, and what we're looking for is like terms. So which ones sort of look the same? Well, what we really want to look for is which ones have the same variables. So we're usually not too worried about the numbers unless they're alone, which is called a constant, but we're more worried about the variables. So let's just start with this x that's right here. So I got 3x, and I'm just going to look around, and here's another one, -6x. So those are like terms because they both have the variable x. Now, if I look right here, I've got this 16t, and I can find another one with a t, that's 4t, so I have 2 like terms with the variable t. Here's another one, I have 5xy, so there can be 2 variables, and I have another one that's like that, which is -11xy. And right here, I've got a -12xyz. So yeah, we can have 3 terms, and here's another one also with 3 terms. And finally, remember I said a number all by itself is called a constant. I've got this 9, and I've got this -6. So when we find the like terms, what we want to do is we want to add them together. So we're basically going to throw a line under these, and they're going to keep the same variable, x, t, xy, xyz, and no variable. So what is 3 plus -6? It is going to be -3. So in total, I've got those 2 terms, but when I combine them together, I just add them together, and I have -3 x's. I got 16 t's and 4 t's, so altogether I have 20 t's. I've got 5 xy's and negative 11 xy's. So altogether I have negative 6 xy's. So you can see that understanding how to add and subtract integers is going to be very important in this unit. I'm starting off on the next one with negative 12 xyz's and adding 5 xyz's. So I've got negative 7 xyz's, and 9 plus negative 6 is going to be 3. Okay, so that is how we group our like terms and then combine them or add them together. Okay, this next one right here can be a little bit confusing and hard to understand, but we have this vocabulary word called an expression, and basically this one right here is an expression, 6x plus 2. So it's an expression because there is no equal sign. So if I look at below, I have this other vocabulary word called equation. Now an equation is basically an expression that tells us what that expression is equal to. So in this case, I've got 6x plus 2 equals 14. So sometimes we have an expression which I can't really calculate anything there. So up above here, when I was gathering these like terms, like these would just all be expressions. Negative 3x, 20t, negative 6xy, negative 7, xyz, and 3. These are just expressions. They don't really, we can't do any math with those. They're just terms that are put together either as a monomial, binomial, or trinomial. So, like I said before, a variable, well, what is that? Well, a variable is a letter or a symbol. So mostly we're going to be using the symbol x. That's the most popular one, followed by y, and finally z. But basically we can use any letter. And in some cases, we're going to actually use a symbol such as pi. We know that pi equals 3.14. So every time you see that symbol, you know that it equals that value. Okay, and the next one is a coefficient. Well, what is a coefficient? Well, it's the number, and the important thing, it's the number that's in front of the variable. So again, when we were looking up here at all our terms, you can see that number right here, 3, that is a constant. It is not a coefficient. So there's no variable at the end there, so it is not a coefficient. Again, it is a constant. So when I look down here, you can see I have some examples that illustrate this. I have these variables, and in front of those variables are some numbers, and those numbers are called the coefficients. And like I said up above, constant is just a number, so that is not attached to a variable. Okay, let's take a look at some patterns, and you can see on the left we've got some drawings of triangles right here. That's one triangle, and it's made up of 1, 2, 3 pieces. And I got 2 triangles, so you'd think if it was a pattern there would be 6 pieces, but if we count them out, there's actually only 5. And on the bottom one we got 3 triangles with 7 pieces. And in this case we're calling them sticks, and I've recorded the information over in this chart, which is called a table of values. Now when we do a table of values, the one on the left is always going to be the x, and the one on the right is always going to be the y. Okay, now in this case we're calling them triangles and sticks, but it's still triangles equals x and sticks is y. So let's look for a pattern. Well, from 1 to 2, that's plus 1. From 2 to 3, plus 1. And from 3 to 4, plus 1, and so on and so on. And on the right hand side, I've got 3 to 5, which is plus 2, and 5 to 7 is plus 2. So to continue that pattern, I would be like 9, 11, 13, and can't do that because notice that the pattern was broken right there. This is actually a plus 4, so I can't continue this pattern here of a plus 2. Okay, so at this point, like I said, the pattern is broken and we need to figure out what is that value right there. Well, I could just, move this 10 down, fill it in with a 7, 8, and 9, such as this. So I'm going to go like this and move that down, and then I would fill this in with a 7, 8, and 9, and that would allow me to then continue this pattern down, 15, 17, 19, and 21. Now that's okay for 10, but what if I said 50? You don't want to move this thing down and fill in another 40 numbers. So what we need to do is we need to remember this equation right here. Y equals mx plus b. Now this is the equation of a line. And later on in math, you'll figure out that that is what we're actually able to graph here. And you can see we got the y right here, and that's just going to stay as a y. And the x is going to stay as an x. So they don't get numerical values. But the m is called our slope. So this is called a slope. And it's going to have a value of y over x, the change in y over change in x. Well, if I look over here, what was the change in y? It was 2. And what was the change in x? It was 1. So the change in y is 2, and the change in x is 1. And you can see that 2 over 1 becomes 2. So essentially what we're doing is we're multiplying the x values by 2. So where's my x value? Right here, 1. What is 1 times 2? So it's like 2 times the x value, which is 1. Well, 1 times 2 is 2. Does that equal 2 right there? No, it's 3. So what did I do to get to 3? I added 1. Now we want to see if this is true for the rest. Well, let's take the second x value that we have here, which is 2. So let's take 2 times that x value, 2, and add 1. 2 times 2 is 4, plus 1 equals 5. And there's our answer right there, so we know that we're good. But let's try it one more time. Let's look at this value of x that is 3 in this case. So it's 2 times x, which is now 3, plus 1. What does that equal? Well, 2 times 3 is 6, plus 1 is 7, and we have a 7 there, so we know that we are correct. So now for us to figure out, well, what is the value of y when x is 50? So how many sticks do we need to make 50 triangles? Well, again, what I'm going to do is I'm going to take the y, we're going to say it's equal to 2 times, in this case, x is 50, plus 1. What is 2 times 50? Well, 2 times 50 is 100 plus 1. So in this case, we have y equals 101. So this would be 101 right there. Okay, so let's take a look at this other example, but notice that this table of values is now horizontal, so it's going across the page from left to right instead of vertical, going from top to bottom. And when it's laid out this way, the x is always on the top and the y is always on the bottom. So remember again, what do we got to look for? Patterns. The x is plus 2, plus 2, plus 2, and down here you can see it breaks the pattern, so we're going to have to definitely do math when we get down to that point. What about the y? Well, 8 to 14 is plus 6, 14 to 20 is plus 6, so this one needs to be a plus 6. So this one right here is going to be 26. 26. followed by another plus 6, which is going to be 32, followed by another plus 6, which would be 38. And now I'm going to want to figure out an equation so that I can calculate this one right here without having to just rewrite this table of values all the way to 30. So again, what's the equation? Y, I'm just going to change the size, y equals mx plus b. So what is m? M is the change in the y over the change in the x, and then it's x plus b. So if I look here, y equals, well, what is the change in y? It's going to be 6. What is the change in x? It's 2. Okay, and we got to keep that x there plus b. I'm going to have to make this a little bit smaller and make it fit in here. There we go. So we continue on here and start simplifying this fraction. So we got y equals 3x plus b, but I don't know what this b is right now. But this 3 is my multiplier that I'm going to multiply by x. So again, just like we did last time, let's look at the 2. So this is going to be y equals 3 times the x, which is 2. Now that's 6. Do we have a 6 right here? No, we have an 8. How did I get from 6 to 8? Plus 2. So that means this b needs to be plus 2. Okay, so my equation is going to be y equals 3x plus 2. So let's see if that works for the next 2, and then if we can see it works for those 2, it's most likely going to work for all of them. So the next x value that we have is 4. y equals 3 times 4 plus 2. What is 3 times 4? It's 12 plus 2. What is 12 plus 2? 12 plus 2 is 14, and you can see that is our answer right there. Moving on to the third x value, which is 6. We're going to rewrite this again. Y equals 3 times 6, the x value, plus 2. What is 3 times 6? It's 18 plus 2. What is 18 plus 2? It is 20. So in this case, we can, right here, we can see that we are correct. So we know that we're correct all the way along. So what is going to be the value of y when x is 30? Okay, well, let's just rewrite the equation. The y is going to equal 3 times the x value, which is 30, plus 2. So what is 3 times 30? It's 90 plus 2. What is 90 plus 2? 92. So right here, this one is equal to 92. Okay, so we're going to take a look at some examples of expressions that are on the left here, and we're going to rewrite them on the right. So in grades 4, 5, and 6, you used a lot of the symbols that you see on there right now, but as we move forward in our math, we're not going to be using those symbols as frequently, and we're going to be expressing these in different ways. Now with the first one, 6 plus x, this is still correct. There's nothing wrong with that, but generally what we do is we would put the variable first and the constant last. So this is better written as x plus 6. So for the second one, you can see I have negative 3 plus x. So that's the same thing. I want to put the x first, but because it's a negative 3, it's going to be x minus 3. I need to keep that negative sign that's here with that 3. Now, look at the third one. It says 6 times x. Now, the problem is when we're using the variable x a lot, we're going to get mixed up. Is that x a times symbol or is it a variable? So we sort of don't use that x as the times. So to rewrite this properly for algebra, it's just going to be 6 times x. But I don't even really need the brackets. So this is generally the way you're going to see it right here, 6x. Okay, I would have, if it was two numbers multiplied together, then the brackets are necessary. Because 5 times 6, you can't write it like that. That's 56. But that is 5 times 6. What about the next one? X divided by 6. Again, it's technically correct, but we would write it like this, x over 6. So remember that this line right there sort of replaces the divided by. We just create a fraction or a ratio out of this. Now the one below that says 4 plus x, and notice that it's in brackets. So we're going to have to do that first and then multiply it by 6. But again, we don't want to use that multiplication sign. So this is going to equal 6 times the 4 plus x. But remember what I said? We want to write the variable first. This is better written as 6 times x plus 4. Okay, the next one says x times 6 divided by 5. So there are no brackets and it's only multiplication and division. And according to BEDMAS, we're just going to move left to right. Now what is 6 times x? It is 6x. Divided by 5, it's the line with the 5 underneath it. Okay, now the one below it has addition and division. So which one comes first? Remember, it's going to be the division. So really what we're sort of doing is we're going to do that first. So how do we do that? It's going to be x divided by 5. And then what do we need to do? We need to add the 6. Now the one below it looks almost the same, except the brackets were installed to indicate that that needs to be done first. Okay, so in this case, we're going to be going 6 plus x first. We have to do that. And remember, we're better off writing x plus 6. And then what are we going to do? We're going to divide all of that by 5. So I could even put brackets around that if I want to. Okay, now below that we've got 3 things that are all multiplied together. So again, all I do is just remove the multiplication signs, and that is going to equal 6xy, which means 6 times x times y. Now we're almost at the end of this one right here. I've got x times x times x. Now, I guess we could go x, 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 but there is a simpler way. Remember that 2 squared is equal to 2 times 2. And 3 cubed is equal to 3 times 3 times 3. So working backwards here, x times x times x is actually better written as x cubed. Okay, and now if we look below the last one, it says 6 times x times y. Okay, so this one is going to be written as 6x, there's 2 of them, so squared, y. So that's 6 times x squared times y. Okay, moving along, we're going to take a look at the distributive law, and that's when we are multiplying a monomial by a binomial. Now you can see right here the 4. We know from earlier that this is a monomial. And the 4 beside the bracket, it means multiplication. And I have an x plus 3 right here, which is a binomial. So the distributive law is sometimes called feeding the chickens. Weird to say that, but basically there's a little saying that the monomial is the farmer, and he goes and feeds the first chicken that's in this little coop that's right here, and then goes feeds the second one. So basically what we're doing first is we're going 4 times x, which is 4x. And then next, we're going to visit the 3. And remember, we're multiplying with the 4. So it's 4 times 3, which equals 12. So the answer to this one is 4x, and this is a positive 12, so it's plus 12. So that is feeding the chickens. The 4 times the first term and 4 times the second term of that binomial. So let's take a look at some examples, and we're going to do it the same every time. What is 5 times 2x? Well, last time it was just 5 times x. So when I have two numbers here, I can go 5 times 2, which is 10. And don't forget the x, it's there. Okay, and now I'm going 5 times 3, which is 15. So I have an expression right here that says 10x plus 15. So let's do it again. 6 times negative 3 equals negative 18. Don't forget the x. 6 times negative 2 is negative 12. So this is quite simple. You're just multiplying this monomial times the first term, and then by the second term of the binomial. So negative 4 times 5 equals negative 20. Don't forget the x. Negative 4 times negative 2 is a positive 8. And on to the last one, negative 5 times negative 6 is a positive 30. Don't forget the x. And negative 5 times 4 is going to be a it's not. It is a negative 20. Be careful with those integers. So negative times a negative is a positive, and negative times a positive is a negative. And finally, we are into the last little section here, and finally again on to real algebra, where we're going to start solving for the variables. So now we have equations, not just expressions. As you can see, we have these equal signs everywhere. So right here, it's equals, equals, equals. So because there's an equal sign there, I can actually determine what is the value of x. Remember, when it was just an expression, it was just like x plus 5. I can't determine anything because I really need this equal sign. So you should be able to look at this and say x plus 5 equals 9. Well, what is x? Well, most of us can do this in our head, just go, well, it's 4. But you really need to learn how we're figuring that out, what system we're going to put in place so that when the numbers become larger or more complex, such as in the form of fractions or decimals, you can do the math correctly. So if you look here, it says that the x, we were adding 5. Now this equation right here, the equal sign means that this side and this side are equal. Now what I want to do in algebra is I always want to just have x's on one side, or some variable, and numbers on the other side. So if I look at the 9 on this side, that's a number, it's good. If I look on the other side, the x is a variable, it's good. But this positive 5, I want it to go to the other side. So if things are equal, it means if I do one thing to the left side to keep things equal, I need to do the same thing to the right side. So I want to get rid of the 5. I have 5, I have a positive 5. So now if I subtract 5, it basically ends up as 0. So in this case, I eliminated the 5. But don't forget, if I subtract 5 from the left, this side over here is now going to be not the same unless I actually subtract 5 from this side. So what we end up with here is x alone equals 9 minus 5, which is 4. Okay, let's move on to the next one that says x minus 6. Well, again, what do I want to do? I want to make sure that everything that's on the left side is only a variable and everything on the right side is a number. and I need to get rid of that 6. I got negative 6, so how do I make that, how do I get rid of that? I'm going to add 6. So I'm doing the opposite. When it was plus, I minus. When it's minus, I plus. When it's negative, I'm going to add. Don't forget, hey, let's keep things equal. Add 6 to the other side. Negative 6 and 6, get rid of that. What do I have left on the left side? X, that's what I want. Then what do I have on the right side? I have 10 plus 6, which is 16. Okay, and moving on to the last one. This one's a little bit more complicated, but I'm just going to show you, and later on we'll get into this with a bit more depth. But again, what do I want? I want the x's on this side, and I want the number signs on the other side of the equal sign. So it's a positive 3. I need to subtract 3, keep it equal, do it from both sides. That kills my 3's. But remember what I want. I want to figure out what an x equals. This says negative x equals positive 2. 5 minus 3 is a positive 2. So if it ever says this, negative x, we don't want to leave it like that. So we're just going to switch it. We're just going to basically go like this. We'll make that an x. So we changed it from a negative x to an x. So if we change that one, let's keep it equal. Let's change the other side as well. It was a positive 2, now becomes a negative 2. Okay, moving down to our second line right here. Now we have 6x. And what do we know that is? That is 6 times x. So it's multiplication. And up here, remember when it was addition, we did the opposite, subtract. When it was a negative 6, we did the opposite, we added 6. So the opposite of multiplication is division. So essentially what we're going to do here is we're going to say, well, it's 6 times x, what am I going to do? Divide by 6. If I divide by 6, let's keep it equal, divide by 6 on the other side. So what do we end up with? 6 divided by 6 is 1. So I basically have the value of 1x. What does it equal? 18 divided by 6 is 3. So basically, I don't need the 1 there. I'm just saying 1x equals 3. So I can just say an x equals 3. The second one, what does it say? Negative 5 times x. So what are we going to do? Divide by whatever's in front of the x. Divide by negative 5. Hey, we got to do that to the other side. Divide by negative 5. Want to keep it equal on the left and right. Negative 5 divided by 5 is 1. I have my x left over. 20 divided by 5 is 4, but the 5 is negative, so it's negative 4. And remember, we're better off just writing x equals negative 4. Now the last one on this line, you can see that the x's are on the right-hand side this time, so it's a little bit different, but it doesn't really matter if I put x's on the left or x's on the right. Basically, we want to set it up the same, where I'm going to get x's over here and now numbers on the other side. Okay, if you don't like doing that, you could actually rewrite it. Negative 3x equals negative 24. But in this case, it's negative 3 times x, so what do I do? Divide by negative 3. Keep it equal, divide by negative 3. That becomes an x equals 24 divided by 3 is 8. Negative divided by negative is a positive. And if we worked it this way, it'd be the same thing. Divide by negative 3, divide by negative 3. Those get canceled, and we have x equals 8. And the last line, and then this video is done. Woo! So it says x divided by 5. So what is the opposite of division? Multiplication. So what are we going to do? We're going to multiply this side by 5. Keep it equal. Multiply that side by 5. Okay? So what is 5x divided by 5? 5 divided by 5 is 1. And I'm just left with x right there. 2 times 5 is 10. Okay, and here's another one. It's got x divided by negative 2. So what am I going to do? Multiply by that same number, negative 2. Keep it equal. Multiply by negative 2. The 2's cancel. So negative 2 divided by negative 2 is 1. And so 1x, or just x, equals 8 times negative 2, which is negative 16. And the last one, again, is a little complex, but for the students that are advanced, I will show it to you. Okay, so in this case, we've got the x that's on the bottom right here. So what we want to do is we want to multiply both sides by the x. We just need to get rid of whatever's on the bottom. Sort of a weird thing. It's almost like a two-step thing. So I'm going to multiply this by x, which means I'm going to multiply the other side by x. What is x divided by x? Well, it's 1. So really, they just cancel each other out. So what am I left with on this side? 12. And what's on the other side? 4 times x. So I'm not finished yet because I still haven't solved for x. But now it's 4x equals 12. There's the equal sign. And this time now I got the x's over on the right, and the numbers will be on the left. It's 4 times x. The opposite of times is divide. I'm going to divide both sides by 4. Cancel. I get x equals 3. And there we go. Done. We will see you in class.